name's Chris Murphy. I'm a principal technical artist. I'm with Epic Games on the DevRel team. Most of you have already had to put up with me on the stage once before, but last time. Today is going to be a session diving into PCG being used for roads and buildings. Can I get a quick show of hands of who attended Daniel's session earlier on PCG? That was the building side. That is few. I kind of expected it to be like 90% of you, honestly. So, but it seems like we're about 60, 70, I'd say, that went to that one, which is great. For context, Daniel answers, I think, some of the questions that I'm like, you may need to research this on your own later for some of the parts in mine. I have a demo that is definitely not my prettiest demo, but it's because I actually decided to rip out a whole lot of stuff to really kind of get it down to like what we can achieve without a whole lot of fiddling around, and the fiddling around being kind of honest, so you can actually see what I was doing versus me skipping a bunch of steps. That said, I will be honest with you, I am semi-skipping 3 steps involved in this process, but I will do my best to walk you through what they were and how I did said skipping. So here's the deal. Right now, if you were to look at YouTube PCG content, 95% of it is forests. There's just lots and lots of forests. I'm part of the problem, right? Like, I want to be clear, I am not absolved. And it's also not a bad thing. It's just whenever we're doing a tool that's procedurally generating stuff that scatters points, our first port of call is, well, why don't we scatter trees? And then they're like, what if we scatter bushes? And yeah, job's done. Looks great. But the problem is that like as we work with PCG more and more, we want people to start looking at how to build coherent points. So how do we start looking at data sets and giving them information to cluster them together, to carry information across, and no longer just thinking of every single tree as a point. Do we get rid of you? Do we keep you? Sorry, I looked right at you as you said that. That felt more personal than it should have been. Like, it starts to become a thing of like, you know, like, how do we consider this as an entire data set? You know what I mean? Like, and that's, in my opinion, when it comes to getting your head around PCG in a really good, like, yes, I know this capacity, this is a big step. The other big part of it involves diving into something like Biome core, but if you want to know what the deal there is, ask me after I've had about 3 beers at the after party and we'll discuss that then. But for this one, I've made a reasonably simple system. We've got a whole bunch of buildings. If you were to paint a spline into the area and move it around, it's generating T-intersections, cross-intersections, T-intersections. I'm a level with you. In the 10 minutes before I started this presentation, when I got up on stage, I was like, actually, there might be a better way to do some of this. And it seems like it's working. So I'm going to teach you that version instead with a few modifications to what I originally was going to show you, but it seems fine. So what I want to do is I want to step through it, and we're going to solve this problem bit by bit by bit. First of those is I don't care about the buildings just yet. You'll come back to you. The next thing is what we're really going to be beginning with is roads. And we're going to find information about how do we build a coherent road system where we're tracking that information of each different kind of road, and how do we like pass that information across. So I'm going to go ahead and get my PCG volume that's currently generating the roads as well, and nuke the site from orbit. I'm going to go to my content browser, and I'm going to spin up a new folder that I'm going to call example. Also, I'm using a 75% keyboard, and it's wigging me out. So if I seem strange at any point, it's because there's keys that aren't here that I am used to. All right, let's go ahead and spin up a new PCG graph. This PCG graph, I'm going to use one of the new samples that we have. Using that in the, I'm really overselling it, but when I create a new spline PCG graph, it's going to be called Simple Roads. And it's popped up on a different screen somewhere. You're over here. All right. Cool. So this is just a simple little sample that already has a spline sampler in there. What this is going to do for me is we are going to sample all of the points along all of the road splines that I have in the world. So we're looking at these bad boys. Now, it's worth noting that those points in the world, there's nothing fancy about them. I've deliberately just left them as just like splines with no cool things going on. There's no safeties, there's no additional stuff there, right? So I'm going to begin and say, hey, look, I want to sample the spline. I want to find every single spline inside of the world that is of type, very loud, road. All right, I'm going to sample every single road inside of my world. Does that make sense? And for us to see this, I'm going to drop it into the map. I'm going to embiggen it. My numpad's gone. This is what I mean. Where are my keys? Who thought this was fun? I did. I was the organizer. This is my fault. All right, so we go to here, and we can see that this is a thing that exists in the world. The problem with splines when you first throw them in is they are 1 centimeter wide. I've had this discussion with the PCG team. They were like, we made the size equal to the scale. If the scale is 1, it's 1 centimeter. And I was like, oh, you're hurting me. So we're going to quickly just, the little enter next to the numpad is also gone. I know it sounds like I'm nitpicking, but I live off of these. Okay. Cool. So I'm just going to crank up the Y and the Z axes so that we can see it. And we can see here that we are now sampling this one road. I want this to sample every road in my world, which is now getting me that. My road volume is clearly not big enough, so let's crank you up. Okay, we've got everything. Great. Love that. Good on ya. So we have all of these roads in the world. And in theory, we could immediately start doing a spline, right? Like I could say, hey, let's make every point 5 meters between each other. And I could say, create spline. And when I create a spline, I can feed that into a spline mesh. Okay. That enter key is hurting me more than I thought it would when I was in rehearsal. All right. So I'm going to spin this up, and we're going to grab just a road. Just as an example. Oh, I could have sworn I hit road. That's fine. Pop that in, and you're going to see this. Now, if your system is running like this, and it feels like it's incredibly slow, then there's a really good chance that what's happened is your mesh needs to be set to nanite. It's worth noting that these run way quicker with modifications when nanite's enabled. Okay. Now, the problem we first have here is, yes, I'm generating roads everywhere, but look at that. Right? Isn't that gross? So the problem we have is we need to identify all of the intersections. And I'll be upfront, when I showed this to the PCG team, like when they watched me do this talk, they cringed a bit and they were like, fine, dude, we'll give you some nodes. But that's going to be like a 5.7, 5.8 situation. And honestly, the thing that I care about now is less about you knowing how to make spline intersections and more about you seeing me solving a bunch of different PCG problems, if you know what I mean. And we're kind of running through that logic. So I'm going to go ahead and I need to figure out where all these splines intersect with one another. I need to carve out those intersections and stick in some little modules that say that's what's there. Now, the thing is that normally if I was to try and like find the distance between 2 points, and I set this to be the length of the spline, what I can do is I can say, hey, if the distance is less than the length of the spline, that tells me that we're probably intersecting something. And I can kind of see that here, right? Like if I, from the center of the points, what is this, amateur hour? All right, there we go. So I come to here and I can see that if I was to get the distance between them, anytime it's below that 500, it's giving me a gray value, which tells me that it's in the center. The problem here is that if something curves too hard, it's going to pick it up as a false positive and be like, that's an intersection. You know what I mean? Like the distance between 2 points when you start getting a squished thing isn't what we want. Also, if you want to enforce this fitting to the very end of the spline, make sure this checkbox is enabled. So how do I go ahead and not detect those extras? And I've got a really disgusting way, definitely made one of my engineers cringe when he saw it, but I'll give you a good idea of just the kind of like little things that I can do here. So there is a function called modulo. Modulo gives you the remainder after a division. So what I mean by that is if I was to say, hey, divide the current index So 0.1, 0.2, 0.3, 0.4, 5. Divide it by 2 and give me the remaining value, which I'm just going to call modulo. That means that what we would see is this. 0, 1, 0, 1, 0, 1, like every odd, even, right? And what I'm actually going to do is I'm going to grab this and I'm literally going to say to it, I want to find the last value. If it's above 0, find the distance between all of those. And you can see here that we've got odd, even, odd, even, odd, even. You get what I mean? And do the same thing again for all of the other things. Odd, even, odd, even, odd, even, odd, even. Okay? And that's doing that for me there. So I've now got 2 sets of data that when I combine them, it's going to look kind of like that, and it's getting rid of any of the things that would have previously done it, because it's actually checking an entire point ahead. There are other ways to do this, don't get me wrong, but I just wanted to run through that. And if I was to get these points and say to them that, like, I now want to get rid of anything that has a, we'll do this one. If I was to say to those points, I want to get rid of any points that have a density of less than 1, they're all I want to keep. I'm going to get them and merge them all together. What I'm left with is not functional. There we go. Sorry. Should have written in the word density. This is what we get for giving me the very last topic. And what you can actually see here is I have every single intersection reasonably cleanly, kind of surprisingly so. I'll be honest with you, the first time I did this, I was like, don't work better than expected. But I've now gotten like all of those points kind of popped together. One thing that's kind of good for me to do here is I actually am going to I'm going to treat these not as intersections, but potentially as special cases, I think. And what I mean by that is I'm going to add the ends of all of these points as well to them. So these, anytime we get to a dead end, I'm going to call that an intersection of 0, if you know what I mean. So that way I'm going to have dead ends, T-intersections, and cross-intersections as the 3 things that I'm kind of caring about here. And if I wanted to grab those additional points, what I can do is I can get these things that we've merged together, and after we do this initial spline sample, you can do a really cool thing and I use really cool in like the nerdiest possible way, whereby this is the spline. Actually, I'll do it off of this one, it'll be easy to visualize. You can say, sorry, I grabbed the wrong one. You can say to a spline that I want your filter elements by index. What filter elements by index does is if I say 0.0, it gets me the first point on the spline. That makes sense? Cool thing, again, kind of cool that like gets you beaten up in school and they steal my lunch money, is if I go 0, -1, that gets me not only the first point, but the very last point as well. That negative value actually counts backwards. So that's now actually giving me every single point that is at the end of a spline as well. Do you see that? All right, cool. So the reason I wanted to do that is if I get all of these and I mix them together, this now is going to represent a cluster of every end of a road and every intersection. That was originally going to be a T, so I'm going to pull you a little bit further in. Cool. And what I'm going to do is I'm going to get all of those, and I'm going to use a nice little function called collapse points. And what collapse points does is I can search for every point within a radius and just crunch them down to being a single thing. I'm going to do it towards the center. Come back here, and now we have a single point at all of these that represents an intersection or an overlap. You get what I mean? Cool. So now that I've got those in play, I'm going to go ahead and I'm going to throw them off to a named reroute node because I want to save this later as something that I can access. And I'm just going to call this like raw intersections. Intersection with a J. This might sound weird, but I actually have to, almost don't really know where the regular enter key is. I type strangely. All right, cool. So the next thing that I'm going to do is we now know where all the intersections are. I now want to go ahead and get our original splines and cut holes in the roads that we had that says get rid of the intersection because I'm adding a spline to that location. Does that make sense to everyone? So just rip that bad boy out, throw in something else in there. It'll be good. So to do that, I go back to here and I simply say, like normally, if we wanted to delete it, I would say, hey, I want to get a difference node and I'll set it to a binary subtraction. And when I plug in the intersections, what we would be left with is that, right? So I can see that's kind of carving those holes that I spoke about, right? The problem is that this is still a continuous spline. We just got rid of one point. So if I was to spawn spline meshes, it would still actually connect both sides of the spline. You know what I mean? Like it would actually run it over the course of it. It'd be like, all right, I've just got to connect it from here to here. We just got rid of the middle point. What I really want to do is I want to say, I got rid of your middle point. Therefore, this is a road segment. And on the other side of the spline is a unique road segment as well. Do you get what I mean? Like treat them as distinct things. So you've got to kind of look at these things sometimes. And there's a bunch of new design patterns with PCG that you just kind of that are really useful to wrap your head around from a tech art perspective. But here's the thing. If I was to just shelve that for just one moment, if I was to do this, where I look at the current indice and I copied that to a value that I'm going to call delta. Let me visualize that so you can all see it. You all hear that? Sounds like I'm about to set up like a smoke machine or something for a dramatic reveal of delta. All right, so I just copied the current number of my spline to a new value, right? We can see here 42, 41, 40, whatever, right? Here's a cool thing. Again, cool in the nerdiest of ways, but if I was to subtract everything and then visualize the number, right? Just one sec. Notice that here, the index is 41, but it was originally an index of 44. 40, 43. Do you see what I mean? So the thing is when I subtracted a number, the index, everything got moved downwards. Do you know what I mean? Like every single thing, because they're all stacked on top of each other, we got rid of this. That's now here, right? Now, what that tells me is that if I was to difference the two, okay, so I was to do this difference, but then I was to subtract, if I was to say delta minus index, okay, and then we visualize that, that actually tells me the delta, so the different index, sorry, the original index minus the new index tells me how many things have been deleted up until that point. Do you get me? Now, the whole point of what I'm doing right now is I'm trying to find a unique number whereby this side has a value of 2 and this side has a value of 3. And because I have a unique number, I now have something that I can tell PCG, this is what splits these up into separate sets of data. This is the difference between here and here, right? So with that in mind, what I'm going to do is run what's called an attribute partition. Again, if you're looking at Epic samples, you'll see attribute partition kicking around quite a lot. And if I'm doing a partition on the last value, which is the delta, and if I come back here, we can actually see that is spawning those roads, but it's treating each thing as a new spline from this location to this location. Everyone's still with me here? Great, groovy. All right, so what I want to do next is, now that we know that that's the case, I want to find information for my intersections. I want to look at every intersection and I want to say, how many points are near you? Because if there's no points, if there's 1 point near you, you're a dead end. There's 3 points, T intersection. 4 points, quad. You get me? So remember that thing that we did before where I said get index 0 and get index -1? If I get index 0 and get index -1 off of this stuff that we've got going on here, watch what this now gives me. It gives me the last point and the first point on every unique road segment, which is, coincidentally, every single input and output of an intersection. Do you see what I mean? Useful. Because now that I know that, what I can do is I can say, hey, okay, if that's all of that data, they're celebrating data. I can say, hey, this is what we've got. What I want to do is I want to get this data. I want to merge all of them together into one giant pool of potential points that's like, from this pool, I will find out which thing you belong to. At this point, I can then run what is called a cluster node. And a cluster says, look at all of these things, find out which of them I'm closest to, and give me information about it. We come back here, cluster 3, cluster 6, cluster 1, cluster 0, cluster 5, cluster 2. You see what I mean? So we've actually created unique identifiers now that says this is the thing that you're close to, right? And that's really powerful because if we know what thing we're close to, we can then start looking at that, fill in the information, generate some stuff, and Bob's your uncle. All right, so I've got this in here. I now know that I've clustered all of these points together. What I really want to do next is I'm going to count the number of things in there, okay? Again, you're going to find a lot of this. My job here is basically, what information can I get? How can I use that as a unique identifier to take the next step for the information that I need to have? And you have to treat these as micro problems. And a lot of these things, I suspect, are going to be like, I think this is eventually going to be like 4 nodes, and I'm going to cry. But for the meantime, we're solving this bit problem by problem. So I've got my cluster, and what I'm going to do next is there's a very handy little thing where, actually, I'll partition them first off. So partition by cluster. We visualize that, and I can actually see this here is a dead end. This here is a 4-way intersection, 3-way intersection. See what I mean? So like we have isolated these all into little clusters they need to be. But with this here, there's a useful thing where we can now say to it, I want to do what is called an attribute reduce. Sorry. And I want to find the biggest number in any data set. Because here's the thing, attribute reduce is it's a little function that lets me look at any attribute in a data set and find out either the max, the min, the join, which just sticks them all together, or the sum of those values. And if I say max, and specifically say, I want to look at the index, that will actually find the highest index in that collection of data. And the highest index tells me how many things are in that collection of data. You know what I mean? Like if it only goes to 3, that means there's 4 points because we count from 0 because of how programming works. So 0, 1, 2, 3, 4 points. So anyway, now that I've got that, I can then say, cool, this is going to tell me how many points we have, how many indices we have, which allows me to kind of pull that data over. Like I can look at that and I'm just going to go, I want you to set, I'm going to call this like intersection size. Oh, sorry. And over here, I can now see at the very end of the value, that has a value of 0. That has a value of 3, right? So I've been able to kind of count this information. Long term, you'll be using domain data, which isn't something I'm going to get in today. It only came in at 5.6, and honestly, it's a little, it's missing some of the functionality that I wanted to have, so I don't want to touch it just yet. But I'm going to look at this information and say, are you greater than 0? And then I'm going to say, are you greater than 2? Because 2 is equal to 3. Oh, my head. So that means that in theory, this would give me dead ends, this would give me t-intersections, and this will give me crosses, right? Let's do crosses just because they're the easiest ones to deal with to begin with. If I get this and we just visualize what we've got, I can see that, yep, that's working, cross, 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 right? So I'm going to do some logic here. How many points could we visually see just then? We could see 4 each time, right? So ahead of time, I skipped a step here, and that's fine. What I did is I made a bunch of these bad boys. And what they are is a little level instance that is just a collection of meshes that will be my intersections. Okay? So this is literally just here's a mesh that will be a 4-way intersection, and I've stuck an arrow out of each one that I tagged as a connector, and I'm going to be putting one of these at every location. You all with me still? So I'm going to get this, and I'm going to say, I want to pop that into every one of those locations. So let's do that. Let's go collapse all of those points. And when you place, instead of placing a mesh, if you place a collection of meshes, and there's a video that I did of this in Prague called First Steps to Advanced Development. So if you're a little confused as to what's going on here, that's because this is the advanced development to, oh, where are we? You know, so go watch that first one, and I'm sure that'll help catch you up to the where I was kind of hoping most folks would be at for this one. I'm going to collapse all nearby points, and I'm going to get load a PCG data asset. Oop, that was silly of me. Load the 4-way data asset. The points are being loaded to these locations. And finally, I'll explain what I've done. I'll just roll back in just a sec. All right, and select it from the value called mesh. All right, I will step back and explain what just happened because I just did a whole draw the rest of the owl. Great. So that's popping these things all into place. What I've done is I've said load the level, copy all of the meshes in the level, and this says find every value with the value of mesh and create that mesh at that location. That's what gets me these 4 locations. If I do the same thing for T-intersections, we have a problem. Can anyone guess what that problem is? Everyone will think you're real smart if you guess it. Wow, look how smart that guy is. Yeah, we don't know about the rotation. So, if I was to place this as a T, what? It doesn't know which way to point, right? So we've got to figure out which way do we want to point. We have a bunch of information here. What's going on? So what I'm going to do is I'm going to look at this and I'm going to go, okay, so what I need to do is rotate the point before we copy all the data onto it. So this is going to go up here. I'm not going to collapse them just yet. If we think about it, I have a point here, a point here, and a point here that represent a T-intersection, right? Which means if I look at the middle of the intersection, this one points that way, this one points that way, and this one points that way. If I add all of those points together, these two cancel each other out, and we're left with just this thing pointing in this direction. Do you get what I mean? Like so that's not too bad to do. What I do is I say, how close are you to the raw intersections should do this, I think. So how close are you to the nearest raw intersection, specifically the center of it? And then what I'm going to do is I'm going to output that as a vector, which is now telling me how far along X, Y, and Z it is to the center of the thing. If you normalize a distance vector, you end up with a directional vector. So I'll do that. And then finally, when I collapse the points down, I can actually tell it, don't just collapse their positions, also look at the distance. Ooh, I don't know what I just pressed. Okay. Also, look at the distance and collapse those values as well. And in theory, that should give me something pointing towards it. So I'm going to make a rotator from the x-axis. It's going to be on the distance value, x, and it's going to be saving to rotation. For anyone that, again, is kind of like, oh God, what's going on? Yeah, my apologies. This is the kind of more advanced PCG side of things, so I am getting into the weeds. But you can actually see here that is now pointing the right way. That is pointing the right way, and that is pointing the right way. Everyone see that? And that's really handy. Like I've kind of like figured that out. And again, it's like a small problem, small problem, small problem. What data do I have? How can I get information and pass it across? Last one that I have is these the one-way intersections, which awkwardly sounds like it would be an easy one to solve, but it does still have its own problems. Because check this out. If you were to set this to be the end of the roads and spawn them, copy this here for a second. Seems like it's working, right? Look at that. It's great. But it's not. They don't know the direction they're facing. They need to know whether they're facing forward or whether they're facing backwards. Like every spline just does this, and it would put both of them facing that way. You know, so it's right 50% of the time. So a cool thing is that when you go to here, and when you first create a spline, you can actually grab a bunch of other attributes from the spline, such as input key or alpha. Input key is pretty useful, so I'll use that one. What that does is the very first point is a value of 0. The very last point is a value of 1. The middle point is a value of 0.5. This tells me that if I look at you and I'm like, hey, you're a 0.1, flip that thing around. You get what I mean? So we go all the way back to here. We grab this, and I'm going to say to it, if input key is greater than, I'm going to do 0.5 just for safety reasons. Then if that's true, copy those onto there. So in theory, everything that's in there right now is correct, or it's not rendering at all. If it's false, get that point and spin it 180 degrees. Those are correct, that's correct, that's correct. Everything in life is good. All right, so we've now got all of that information. We can see where we've gotten it to. Now, I have a bunch of these red arrows. These red arrows aren't just for your benefit in terms of like knowing which way it's pointing. I've actually tagged every one of these red arrows with the word connector. So inside of my level instance, I just added an actor tag that said connector, right? And what I'm going to do is, as before, I'm going to say if connector is equal to, if it's equal to false, actually I want you to be down here. Did my logic backwards. All right. So that's now saying get the points that aren't connectors and render them. But all the points that are connectors, let's do something spicy with them. Okay? So what I'm going to do here is all of the points that aren't connectors, I'm going to do this. Just for context, those are all my points without connectors. See how there we've got those little white cubes that are now rendering at those locations? So there is a really, really powerful node in Unreal called attract. Okay? Now, attract is definitely one of those things that is, it's more useful than it originally sounds, because what I'm going to do is I can get all of my original points, okay, and I can attract them to my connectors. So I can look at the original spline that we had and say, how close are you to the nearest connector, pull the end of the spline and stick it to my mesh. You get me? And this is really cool, because if I can reach into the other things and kind of pull them around and do stuff with them, we can, that's a really, really valuable thing. Because check this, right? Like if I get these, I say, I want to pull towards that. And it's like, well, what data do you want to pull? And I'm going to tell it that I specifically want to pull when we first had when we cut up all the splines, I want to grab that data. So just after my partition data, okay, I'm gonna make this a named reroute that I'm gonna call something like cut splines. Great. Go over here and I'm just gonna cut my cut splines. I'm gonna spell it correctly. So that's actually now attracting my cut splines if they're within 100 centimeters. I might increase the value of that a little bit. So see how these are big dots here now? That's because those ones there are actually, they're not the, remember it was a little tiny box before? It's actually grabbed the nearest bit of a spline near them and gone and pulled it over to it, right? And that's really, really valuable because this is now pulling it in. And honestly, I kind of actually want to go even bigger of a value. You can see that when I did that, we kind of pulled that in instead, see? And with that data in place, what I can actually do is I can start to say, I want to get you and I want to cut sections out, or maybe I want to collapse points down, et cetera, et cetera. I also don't just want to attract your position. Notice these aren't fully straight. They're kind of weirdly skewed, right? It's because the attract node can actually attract anything. It doesn't just have to attract a position. I can pull any value off of the nearest thing in another set of data. So I could pull the rotation from them. I could give them an arbitrary value like, I don't know, heat factor, and it would pull heat factor into the nearest thing that it could find. In this case, I'm going to do like simple values. So I'm going to do rotation and pull that in as well. And you can now see that that's fully dead on with where the original connectors were. I'm also just going to do a collapse points because the collapse points will let me get rid of, there's actually like 4 boxes on the exact same location right there. So by doing a collapse points, I can kind of nuke them all. With that done, this is the next bit that I will skip a step on. And that is that I have made a function ahead of time called tangent from rotation. And I did this because I just wanted to save some time in this presentation. So all this is doing is saying, look at the spline that's coming in. If it's the end of the spline, set the value for arrive tangent, or in this, sorry, leave tangent, to be equal to the forward vector multiplied by the direction. So basically what happens is normally a spline says, I'm facing this direction, and this is how far I'm facing in this direction, but I've gone and just vacuumed it towards the nearest thing that I could. This basically says, look at where you're actually pointing now, and figure out your logic again as to which way your tangents are. I'm gonna throw all of this into an epic learning document afterwards, so don't stress. This will all be in a good place pretty soon. But this point here, sorry, I actually missed a little step. I need to make sure that I'm outputting my tangents. This point here is, in theory, when I plug that into there, and when I get this, and I run that little create spline that we had before, should, give me one moment, I know why. So when you call create spline, you have to say apply custom tangent. Good. And now every single one of these pieces is now being kind of vacuumed and stretched to match the thing that we've got here. You all still with me? So the cool thing is with this intersection system, again, like I've done this really quickly, and it's more about showing you about the logic of solving these kinds of problems than it is about you going home now and creating the best road system for your game. But what I wanted to do here is, yeah, kind of step through them, but I think it's really, it's valuable to know some of the tools at your disposal. So what I'm going to do next is I'm going to skip through setting up the buildings, and I'm going to just walk you through how I set up the buildings, because it's actually basically the same logic as to what we just saw, except I've gone ahead and very slightly different configuration. So if I go ahead and I save, and I grab my city generator, it should do it. Whew. There was a brief moment there where I was like, is that another function? Okay. So this seems like it would probably be complicated, right? But let's step through the logic of what we've got that's kind of doing this. All right. So initially, I'm going to turn off the building at the end because it's getting in the way. Initially, I'm finding a whole bunch of points on the ground, and I'm literally saying, find every point that's kind of near the roads. Those are where I'm going to let buildings be. Afterwards, I'm subtracting the actual roads themselves, which gets me a ton of points that are now all pulled in, right? Does that make sense? So we've now got these kind of like city blocks of potential area that could be a building. Afterwards, this is where, again, some of the stuff might seem a little odd. I'm using the collapse points node to find a bunch of just singular points. So I'm literally just saying collapse points to a 6,000 unit radius, right? And that's just finding anything within 6,000 units and pulling them all together for a single point. And what I've done is those are going to be the seeds of buildings. Because what I'm actually going to do is I'm going to go through and my buildings are going to say, this is building number 1. Look at any points nearby. If they don't have a building ID yet, they're building number 1 as well. Run through it again. Are there any points nearby? Nope. Oh, sorry. Yep. They don't have an ID. Building 1. They get to here. Are there any points nearby? Yes, but they're building number 2. We go, all right, cool. You have fun. And we back up. So to do that, I say every building is a value of -1. So I've said I'm treating -1 as like you don't have a building. I'm using the attract node to attract the index of the building to be the building ID number. So building 0, building 1, building 2, building 3, building 4, building 5, right? Now, I've written a little function that is terrifying to write because it's recursive, and that's always scary. So if you ever do write one of these things, make sure you pause generation while you're doing it, or you're gonna crash. But essentially what this does is this steps through and says, do I have a building ID? Yes? All right, well, it's been assigned a building, ignore it. No? All right, come down and attract it to the nearest buildings that do have IDs. I then say, if the number of buildings that have IDs is equal to the number of buildings that were free, so basically I say, is there space for me to keep expanding, or have we filled every point? I literally run this function inside of itself, otherwise I bail out. And what that actually does is that leaves me with every single point now having a building ID of 1, building 2, building 3, building 4. And if we run a partition on it, that then splits that data. We can actually see this if I do it here. If I was to look at this building, or if I was to look at this building, or this building, see what I mean? See how that's giving me the shape of those city blocks based on like how we've expanded until we either ran out of -1s or we hit something else, right? Inside of PCG, you can actually then just find a convex hull, and what that does is it gives you this. It'll actually draw the outside of the shape of the city block. Do you get what I mean? Now I've done something kind of dodgy here, which is I've done the exact same function again, where I went and I got the original building points and I subtracted the function that I just made. So I drew that outline and watch what happens. So see this? And then I go back and I subtract it from the other, and I'll go all the way up to the spline again so we can see it. But because I subtracted the outer layer, it actually gave me some space between the buildings. Do you know what I mean? Like, because I kind of drew the outline and then said, remove all these points, I don't care about you. It actually gave me some spacing to the next thing. Yeah? Now, with that logic in play, I have a function here that now looks like, again, it looks like I'm doing draw the rest of the owl, but conveniently, this isn't as bad as it seems. And I say that because I'm going to save everything, and I'm going to open up. If you go to your plugins folder, why are we not showing plugins by default? What a world. If you go to your plugins folder and scroll all the way down to PCG, and you go to geometry interop plugin, obviously, you'll find this level. This level, I think, is very cool because it does this. If I was to get this box and move it in, move it out, move it in, PCG looks at all the boxes in the map, figures out an outline around them, and then wraps those walls in meshes. See what I mean? And all I've done is I've copied and pasted this logic here into my own buildings and put in some slightly prettier meshes. So that's why I said it's not that big of a lift, because I'm literally grabbing a sample plugin that's already in the engine that you can then work with for your own nefarious purposes, okay? And I want to step through what that's doing because it seems scary at first, but it's not that bad. So initially what this is doing is it says, find every building that has the tag mesh building tag. So it basically says, these are the things I want to create an outline around. Create a cross section of them, which gives me a thing that's called extrude vector, which is like how tall that building is. At which point it runs a function called building sample. This is what I straight up copied and pasted into my own thing. Now, the things you need to know here is PCG has a system called grammar, okay? And how grammar works is it allows you to use plain English to tell PCG how meshes stick together. And what I mean by that is this says add one main floor and then intermediate has an asterisk after it, which means add a main floor and then add as many intermediate pieces as you can possibly fit, right? So it's like a sentence that describes what we want it to be. And if I scroll over here, when we duplicate all the cross sections, it's basically told that a main floor is 300 units high and an intermediate floor is 250 units high. And it then says, all right, I lose my main floor, that's 300 units. 250, 250, 250, oh, we're out of space. That's what I'm getting there as my thing. Does that make sense? And the cool thing is that not only does this work for us putting in the floors upwards, but around as well. Because if I go to here and then look at the next step, spline to segment basically splits up every section of a PCG between the 2 points. And select grammar does the exact same logic, whereby it says, look at how big the piece that I'm trying to fit into is. If it's the main floor and it's greater than 499 units, the rule we're going to use is CWW1 asterisk C, which means add a column, randomly pick between W and W1 as many times as you possibly can, but make sure that there's a column at the end of it as well. Do you see what I mean? So like the types of brackets you use mean different things, but it allows you to have like logical rules that explain what these things are. And it's a little bit to wrap your head around, but if I go back to the demo level that we had before and I look at my setup, so I go back to this city generator with this generate building. Like, I'm not kidding when I said I copied and pasted it. Look at that. The only thing I did is I got rid of rendering floors because it was rendering just an insane number of meshes and it was just making me sad. But like if I go to my select, if I look at my, my grammar selection over here, I made a main floor and then I said intermediate and upper. And I can see the upper meshes are these guys here. You know what I mean? Like, and I go back here and I go generate building. So when these were thrown in there, and we were doing the cross sections, upper is this. But I've also told it, you can actually even tell it which things are considered scalable. So if it's like I'm trying to fit into 1,500 units, and I've gotten to 1,400 units, I'm allowed to stretch this floor by 1 meter in that direction. Do you know what I mean? Like, you can kind of tell it which ones are flexible versus which ones aren't, or you could tell it to bail out early. That's up to you. Okay? So this grammar rule set is something that is really important to wrap your head around as you start moving into this. There is a great docs page on it, which is here. It's called Using Shape Grammar with PCG. But you can see a much cleaner example here is like if I'm setting a fence up, I think it's just a picture at the top. If I was setting a fence up, I could tell it, put the start of the fence and put the end of the fence, put random fence pieces, and then if you ever do a gate, make sure either side of the gate has a column. And they can all be unique sizes that are all fitting in together, et cetera, et cetera. And the trick with grammar is that it sounds complicated, but when you wrap your head around it, grammar becomes really, really, really powerful at having human readable logic as to what we want. I want to have a doorway, but only one doorway on any side of a building. And if there is a thing on that side of the building, make sure the doors have columns on either side, push them up between the floors, et cetera, et cetera. You know what I mean? Like, you can get this common language running through things. And you can also seed your grammar and rule sets from data assets and things like that. That's a whole different kettle of fish. But I wanted folks to kind of just get an understanding of just grammar existing, stepping through general rules that I use, and just like logic of like, how do I pull attributes from different places to try and populate information into things. I know it's a little bit of a chaotic talk, but hopefully this has been useful for folks. I'm more than happy to chat to folks after the session a bit during the after party. But in the meantime, Unreal Fest Bali is, the sessions are all done.